Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about the molecular geometry versus electron group geometry of molecules. So let's get into this. So let's first cover what molecular geometry and what electron group geometry are. So molecular geometry is the geometry or shape of the actual molecule based only on the bonding electron groups, which means the bonded atoms. There we're actually ignoring the lone pairs. So whatever shape the molecule actually has, ignoring the lone pairs, that's the molecular geometry. The electron group geometry is based on the total number of electron groups around your central atom, including bonded atoms and lone pairs. So bonding pairs or bonding groups and lone pairs are included. And so we count up all of those groups and we give the shape that it would have if those lone pairs were actual atoms. So we kind of look at the whole thing and determine the shape based on everything around it. So let's go through a few examples here. So here we have in this row we have a steric number of 3. So that, remember, that steric number means the total number of electron groups around your central atom. That includes bonded or bonding pairs of electrons or bonds, and that includes also lone pairs. And so remember, when we're thinking about bonds or bonding groups, that includes double and triple bonds. So when we think of single, double, and triple bonds, those double and triple bonds are not thought of as 2 groups or 3 groups. A double bond is considered 1 group, and a triple bond is considered 1 group. So we don't separate those out. We don't say, oh, that's 3 groups. So just a little information there. So here we have 3 groups. We have 3 bonded atoms to our central atom. So the molecular geometry of this molecule is trigonoplanar. So the electron geometry is also trigonoplanar because, again, the electron group geometry is based on the total number here. So if we think only about electron group geometry, we're looking at the total of everything around the atom. So here we have 3 bonding groups. So all we're doing is we're counting the bonding groups, and so we have trigonoplanar here. If we look at the bonding groups around this molecule, we have a lone pair and we have 2 bonding pairs. That's 3 bonding groups. I'm sorry, that's 3 electron groups total. So because there's 3 electron groups total, then the electron group geometry is going to be trigonoplanar again. So this molecule with 3 bonding groups is trigonoplanar electron group geometry. And so this molecule with 1 lone pair and 2 bonding groups is still electron group. Its electron group geometry is still trigonoplanar. But when we're looking at the molecular geometry of that, we ignore the lone pairs, right? And just look at the shape of the molecule. So the shape of the molecule here with the atoms is bent, right? So even though its electron group geometry as a whole here is trigonoplanar, the shape of the molecule or the molecular geometry is bent because we're only looking at the atoms and not the lone pair. So the lone pair is still there, right? Which is why these 2 atoms get pushed down and causes the bent molecule, the bent shape. Okay, so let's look at number 4. So here for number 4, we have 4 electron groups. So every molecule here in this row has 4 electron groups. Some molecules have lone pairs. This one has 2, or this one has 1, this one has 2. So for this molecule, you have 4 bonding groups. And because you have 4 electron groups, all of them are bonding, it's a tetrahedral shape for the electron group geometry, right? Because we're considering the total electron groups. So the total electron groups here is 4 bonding groups, no lone pairs. So that is going to be electron group geometry of tetrahedral. This molecule has 4 bonding groups, 4 atoms bonded, but it has 3 atoms bonded, and it has one lone pair. So that's still a total of 4 electron groups. And so because it has 4 electron groups, the electron group geometry is the same. So it's going to be tetrahedral. So the electron group geometry of this molecule that has 4 bonded atoms is going to be tetrahedral. The electron group geometry of this that has 3 bonded atoms, 1 lone pair, is still tetrahedral because it's based on the total electron groups. This molecule here has 2 bonded atoms and 2 lone pairs, so that's a total of 4 electron groups. So the electron group geometry is still tetrahedral. So all of these have electron group geometry of tetrahedral because it's based on the total electron groups. But if we're looking at only the bonding groups, the bonded atoms, then we're going to look at, that's going to be your molecular geometry. So here we have 4 bonded atoms, no lone pairs. So that means that the molecular geometry is tetrahedral. So the molecular geometry and the electron group geometry are the same for this molecule because we don't have any lone pairs. We just have bonded atoms. But here, as soon as we introduce the lone pairs, the electron group geometry and the molecular geometry are not going to be the same. So here we see that we have a total of 4 electron groups. So that means the electron group geometry is tetrahedral, but we have 3 bonded atoms, 1 lone pair. So when we're looking at the molecular geometry, we're only looking at the atoms, and that's what gives us a trigonal pyramid shape. So the molecular geometry for this molecule is trigonal pyramid, but the electron geometry, if we're considering everything, is tetrahedral like this one. So same for this one. We have 4 total electron groups. So that's going to be electron group geometry of tetrahedral. And so but when we're looking at the molecular geometry, we're just looking at the molecule, the atoms themselves. And so when we're looking at that, that's a bent shape. So the molecular geometry is bent, but the electron group geometry is tetrahedral. Okay, so you can see for these two, because we have the lone pairs, the electron group geometry is not going to be the same as the molecular geometry. But when you have no lone pairs, then the electron group geometry and the molecular geometry is going to be the same. So let's look at this one finally. It's the same thing here. So when we look at the electron geometry of all of these have in common 5 groups, 5 electron groups. So the difference is the number of lone pairs that are there. So for this one, there are 0 lone pairs. So the electron group geometry is going to be the same as the molecular geometry, which is going to be trigonal bipyramidal. So trigonal bipyramid is the electron geometry of this molecule because you have 5 bonding groups, no lone pairs. Here you have 5 electron groups, but one of them is now a lone pair. But because we're looking at the total of the electron groups, then for the electron group geometry, it is still trigonal bipyramid. So this is also trigonal bipyramid. This has 5 electron groups around it, 3 bonding groups, 2 lone pairs. So this is going to be electron group geometry of trigonal bipyramid as well as this one, because they all have 5 total electron groups. Some of them have lone pairs, some of them don't. But what they have in common is that they have 5 total electron groups around the central atom. But when you're looking only at the molecular geometry, we only care about the bonding electron groups, the atoms themselves, the bonded atoms. So for this one, because we have 1 lone pair, but we have 4 bonded atoms, the electron group geometry is going to be based on all 5 groups. That's going to be the trigonal bipyramid. But because we're ignoring, for the molecular geometry, we're ignoring the lone pair. We're looking at the shape of the bonded atoms. That's going to be a seesaw shape. So the molecular geometry is seesaw shape, but the electron group geometry is going to be the trigonal bipyramid. And then the same for these as well. And so you can also follow the same reasoning for the 6 groups here. So the octahedral electron geometry is based on all 6 groups. All of these have 6 groups, electron groups around them, so their electron geometry is the same, octahedral. But when you start throwing lone pairs in there, the molecular geometry changes. So this one, the molecular geometry is square pyramid. The molecular geometry is square pyramid. The molecular geometry for this one is square planar. The molecular geometry is T-shaped here, and the molecular geometry is linear. But for the electron group geometry, it's all the same because they all have 6 electron groups. So all of the electron group geometries for these is going to be octahedral. So that's the distinction between molecular geometry and electron group geometry. So I hope this was helpful. If you enjoyed this video, if this was a learning experience for you, please hit that like button, subscribe to my channel, hit that notification bell so you can be notified by other videos I put out. Put a comment in the comment section. Let me know what you think, and if you have any questions, I can answer. Thanks for joining me. Have a great day.